So in this new video, we will discuss visual inspection. So what is a visual inspection? It involves a systematic process conducted in three stages, like pre-welding, during welding, and post-welding. So, so the summary title is why we require to do visual inspections, because we are doing other NDTs like radiography, UT, MPT, etc. So, what is the requirement of a visual inspection? So, it is done to minimize the number of welds rejections. So, rejections occurs during the NDT. So, we need to minimize the number of weld rejections. And it also improves the welding productivity. How it we can improve the welding ability by keeping the need for rework to an absolute minimum. So visual inspections, we are achieving these two to minimize the number of weld rejections and improve the weld productivity by keeping the need of rework to a absolute minimum. So visual inspection means examining visually through the eyes to determine the surface discontinuities. Like we said, the visual inspection is examined visually through the eyes to determine the surface discontinuities. So what are the advantages? It is easiest to perform, it is less expensive among the NDT methods. So we can maintain the acceptable welding quality, prevent welding problems. So possibility of preventing welding related problems rather than finding the problems that may already occurred. So this is the main advantage of visual inspections. We have the possibility of prevent the weld related problems. But other methods, we are finding problems that already occurred. So NDT is typically for the inspection of completed welds, usually design conducted to find the welding problems after the fact when the weld is completed. Visual inspection is utilized to prevent the welding problems as happening in the first place. So various stages of visual inspection. Pre-weld inspection, then during welding operation, and the post-weld visual inspection. Pre-weld welding inspection is provides opportunity to detect the correct unacceptable condition before they develop into actual welding problems. And during the welding operations, we can prevent the problems through verification of the welding conditions and the procedure requirements. What does this mean? This means that during a welding inspection, during the visual inspection during welding, we are checking the welding parameters like correct current, travel speed, shielding gas flow rate, etc. Interpass cleaning, ensure proper cleaning, like buffing to remove slack, etc. Then environmental conditions like wind or rain did not interfere with the welding processes, and defect detection for the immediate signs of issues like lack of fusion or excessive spatter. These are the inspections during the welding. So simply saying, the pre-weld inspection, we are doing the material verifications like correct base material, filler materials, joint preparations, bevel, pipe bevel angles, root openings, alignments, cleanliness like rust, scale, moisture, grease, oils, etc. We can cause defects like porosity, welder qualifications, assigned welders are properly certified, etc. So the pre-weld visual inspections, we are checking the alignment, cleaning, etc. Alignment it should be, the bevel angle should be 60, that can be 30 plus or minus 5 degree. Root gap is 3 mm maximum, and the root face is 1.6 mm maximum. Thickness is 15.9, etc. That after post welding, the reinforcement also should be 3, it should be 3 mm maximum. It has a how many beads? One root bead is there, then we have 2 hot bead, 3, 4, 5, 6, 7, 5, 6, 3, 4, 5 are filler passes, and finally is capping layers. That is root pass, hot pass, fill passes, and the capping layer. 1, 2, 3, 4, 5. One, two, three, four, 5. So here bevel angle is 30 degrees plus or minus 5. Root opening is 3 mm maximum, and 1.6 mm root face. Alignment is should not be more than 1 mm, and other conditions is written in the in our method statement. So as per our specifications, the pipe thickness up to 26 mm, preparation shall be V type. With beveling is 37 degree 3 seconds, 30 minutes, 37 degree 30 minutes plus or minus 2 degree. That means 35 to 39. The piping thickness over 36 mm preparation had been done as per another type approved by Transco. So these are the root openings. Greater than 250 mm dia, it is 2.5 to 3.5 mm. Internal misalignment shall not exceed 1 mm for the welding of root pass. When the GTW root pass is there, it should be not exceed 0.8, misalignment should not exceed 0.8 mm. If different thickness, the misalignment up to 3.2 mm may be improved by internal machining, and the taper should not exceed 1 in 4 max. And either way, minimum required wall thickness to be maintained. Tone മേളിലുണ്ട്. Another thing we are examining during the visual inspection, that this longitudinal butt wells of adjacent pipes shall be separated by at least 100 mm or 5 times the thickness of the thicker pipe. Short pipe lengths between the fittings can be used, and butt welds should not be closer than 75 mm, 5 times the thickness of the thicker pipe. And we are checking for the shape of the weld bead, the crack, overlap, undercut, slag, spatter, finishing condition of the tack welding, and this is the acceptance criteria of the visual inspection. If it is undercut is less than 0.15, it is accepted. 0.5, it is depth is more than 1 mm, and uh, and if the depth, the undercut depth is a point between 4.5 to 1 mm, and the length is more than the thickness of the base metal, then we need to repair it. Overlap should be very smooth. The welding leg length internal should be 0.85 t, and the external length should be 0.85 t plus gap. And the B shade should be smooth, and the spatter should be removed perfectly. So undercut, this is the main thing to remember. If it is less than 0.5 mm, we can assess it, and if it is less than one, is more than 1 mm, or it between 0.5 mm and 1 mm, but the length is more than thickness of the base metal, then we need to repair it. Okay. So that is the acceptance criteria of a visual inspection. We go further with uh, VTAI. So welding parameters we have already discussed. Again, we will discuss about the correct current, travel speed, shielding gas, gas flow, etc. Gas flow, shielding gas is not, we are using SMAW, so there is no shielding gas. Correct current and travel speed. So travel speed we discussed already. Again, we will see here travel speed here. So this is the travel speed, mm per second. 1.17 to 1.58 is a root pass. Here travel speed, capping layer travel speed is more, 2.43 to 3.46, and it is ascending. It is in ascending order from root pass to hot pass to filler pass to finally to the capping. The heat input also is higher for root pass, 1.5 to 2.2, and it is gradually reducing. Filler pass, it is more taking more time, that's why root pass. The hot pass, it is between, it is little electric, so we can, it can go faster. Filler pass 2.19, 1.19, and the last capping layer is 0.99 to 1.28. So finally the heat input will be 0.83 to 2.31, 0.83 to 2.31, 0.83, 0.83, 0.83, 2.31. That is a heat input. Then what are the other parameters we are discussing? Correct current travel speed. So current, what is the current here? Polarity amperes. That is a 80 80 to 120 165. That is the ampere. Correct current, voltage, travel speed, polarity. Polarity is not changing. DCEP we are using for SMAW. So this one we are checking, uh, like correct current 0.83 in amperes, what is the voltage, then the travel speed, then the shielding acid is not there for our SMAW. Then interpass cleaning, so buffing for to remove slacks which we performed. The environmental conditions like wind or rain which cannot interfere with the welding process. The defect detection, immediate signs of lack of fusion or excessive spatter. This one we will discuss in the weld defects. Then after inspection, we are assess the final quality. We will check the reinforcement, weld reinforcement, that should be not more than 3 mm. Surface should be cleaned of any slack or spatter. Then we require flashlight, magnifying glass, welding gauges like fillet weld gauges, calipers to measure the weld size, like length, profile, etc. The borescope we are not using. What is surface defects, like look for visible cracks, porosity, pinholes, undercut grooves at the edge, overlap, underfill, etc. Weld profile and dimensions. Weld bit should be uniform, and the convexity, concavity should be appropriate to the joint type. The alignment, for any misalignment of the pipe or distortion caused by the welding process. If some surface defects are found, of non-further dusting like dye penetration dusting or MPT should be used to confirm their extent. For internal dimensions, we have to go back. We have to go with the ultrasound setting or the radiography. So that's about this VTAI. So this is the IR for the weld visual. So that this is the weld visual inspection report. Here WPS number, material grade, APA file grade B it is mentioned. It's wrong, actually it should be APA file X52 52. So joint details are there, heat number, diameter number, thickness, etc. Fit up date, date of what is this heat number. So heat number can be termed as a material passport, ensuring transparency and accountability in the supply chain of the steel components like pipes. What is happening here? It's a unique code. It identifies a specific batch of steel from a single furnace melt. It is crucial for traceability. It links the pipe to its material test report of the for chemical and mechanical properties, and ensures quality control and compliance in the industries like oil and gas. It is typically stamped on the pipe or tag, allowing the verification back to its mill records, essential for tracking defects or confirming material standards. Okay. So that's the heat number. So heat number we discussed. Then our diameter, thickness is 12.7, fit up date of the weld, then the root and hot pass, filling, capping. There is two welders are there. That's why it is W106 and W102. No back welding, and remarks is not applicable. So this is the drawing. This is the weld plan. Okay. Now in this one we have this radiographic test. This is the second submission of the IER. This radiographic test we will discuss during the radiographic video. So that's about the IR. Now we need to discuss ITP and the QCR form. Actually, this is the QCR form. This is the QCR form. Daily visual inspection report. Now we need to discuss ITP and what's the difference between ITP and the QCR form. So for ITP we need to go to our what do you say, our method statement. Okay. Again in the ITP we are discussing the inspection visual inspection, like prior to welding we are checking weld preparation, alignment, fit up, cleanliness, etc. During welding we are checking with regards to WPS, filler material, joint preparation, cleaning, etc. Again, here we are also checking the current travel speed. Also, we will check during this welding, and the what do you say, the buffing, the cleaning between the layers. That also we will check. Then after welding, the accessibility of welds through weld visual inspection for defects like arc strikes, external reinforcement, weld spatters, and other defects, porosity, surface porosity, etc. Then, if it is all okay, we will send it for a NDT, like a radiographic or ultrasound test. Okay. So cracks, lack of fusion during the NDT, cracks, lack of fusion, and lack or excess of penetration, etc., are the causes of our causes of rejection. Okay. So this is our excavation profile or cross section. We are it is our minimum width is 2.5 meter, and IL difference between this one is 3.5, and we are providing dune sand with geotextile wrapping for this surround, pipe surround, and this material is approved backfill material, 95% compacted, warning tape, geotextile layer with a 50 mm thickness sand protection layer. It is provided here actually. Now this one we will discuss during excavation again. So weld holes shall be 1 meter deep from the BOP, and it's again it should be 1 meter here, 1 meter here. Overall width should be 2.5 meter minus the diameter that is shown here. Now our pipe is 1.4, 2.5 means 1.5. So minimum we require 0.5 here, but actually here we require 1 meter width and 1 meter depth from the BOP for welding. This is the how spool is unloaded inside. So this is temporary support location, and it is from the 1 meter we have to provide the sandbag area. It should be holiday tested before support location, and then only it is 1.5, 1.5, and it is 2 meter. It is 0.75. So here comes testing and inspection plan. We'll rotate it first. So this is the installation of for commissioning of pipes, our ITP, inspection test plan. Inspection test points are a check for completeness of the packing, verify the materials, verify the material received at site, have completed MDRB. Inspection, what is MDRB? So, what is this MDRB? It is a manufacturer's data record book. And now check for damages, painting, verify pipe marking, identification, cleanliness, preservation of flange faces, receiving inspection request, check for spare parts if any. SS piping shall be preserved in order to avoid contamination with the CS pipes. So, inspection of completed civil work. Check for any pipe support installation, trenches, their levels, completeness with as per drawing. Required test has to be carried out for pipe laying underground, FDT, compaction test, etc. Then we have this WPS, third party WPS, PQR, WQR submitted for approval. Then have weld machines. You need calibration certificates, baking, holding ovens, skewers, storage and control of welding consumers. SS welding consumables shall be mixed with carbon steel. Post welded heat treatment not applicable. Uh, if applicable, it should be post welded heat treatment reports should be there. So that is the visual inspection of completed welding, checking welding quality, workmanship under proper measuring tools, fabrication and welding bay for shall be separate from CS. Internal weld surface as orifice flanges shall be ground flush. So that's about this ITP. So what is this difference between ITP and the QCR form? So ITP outlines what, when, how, and by whom the inspection and test should be conducted. It specifies the acceptance criteria, reference documents, frequency, involved parties, mandatory checkpoints like hold points, witness points, review points, etc. It is proactive roadmap to ensure compliance and quality. QCR form, on the other hand, it is a quality control record. It is an actual record or form filled out during or after the inspection to document the results. It serves as objective evidence that an inspection specified in the ITP was performed. So some sources also mentioned that one is not important. So to put it in a so ITP is the plan and inspection, then the QCR form or is the resulting record after the inspection. So in a more formal way, it's a comprehensive proactive quality assurance document. It outlines the systematic roadmap for all inspections, and it has the fundamental document. It involves activity, reference document, standard acceptance criteria, inspecting party, the inspection point type like hold point, witness point, review point. So what is the hold point? A mandatory verification point where the work must stop until further inspection and approval is required to proceed. So in witness point is the inspecting party is notified and invited to witness, but the work can be proceed after a predefined waiting period if they are absent. But the review or surveillance point is the party may conduct random check or simple review the inspection records later. Not notification or physical presence is mandatory for work continuation. So QCR form is a checklist used by the inspector to document the actual results and findings of an inspection or a test. It contains inspection details, date, time, location, person involved, a description of the item, results, a record of measurements, observations, clear pass, fail against, and no defect non-confirmation document. If the works fails the inspection, QCR note the defects and usually reference as a separate non-confirmation report for tracking the corrective actions. Sign off. The signature is on the contractor QC, sometimes client or third party confirming the results. Relationship in the inspection process are ITP is a master plan defines what must be need inspecting and when. Request is the Inspection request is submitted by the contractor based on the ITP schedule to notify the client inspector that the work is ready for inspection. During inspection, the results are recorded in the QCR form. It is also called as inspection and test record, or ITR. Verification signed is documented proof that work met the required quality standards, allow the proceed to the next stage. So that's about this ITP and QCR form. Now we'll discuss. So ITP is a plan which have this all kinds of acceptance criteria, reference documents, the frequency of testing, who is involved, which is the inspection points, etc. Where the QCR form is the a record that inspection is or tests are conducted as per ITP. So both are ITP is a plan and inspection the QCR form is a record. Now we'll finally, so I think most of the things are covered, but one more definition is why we exactly require visual inspection based when concerned with the NDT or radiography. Okay. Before that, we need to discuss what is the importance of various visual inspection. For the during the prior to the welding, we are verifying the pre-weld setup. It involved a dimensional inspection of the root openings. If the root openings are too tight, what will happen? It may cause inadequate root penetration. If the root openings are too large, it can cause over penetration. The groove weld bevel angles, if too small, can cause a lack of fusion. If too large, can cause a distortion of the weld joint from overheating and excessive shrinkage stresses. So there's first we discuss root opening. Root opening, what is happening? If it is too small, there will be what will cause inadequate root penetration, and if it is too large, it will cause over penetration. So inadequate root penetration, and if it is too large, the root gap is too large, it will cause over penetration. And some and the groove weld bevel angles, it is too small, can cause a lack of fusion, and if it is too large, causes a distortion of weld joint from overheating. So too much weld deposits will be there, and too much overheating, and causes excessive shrinkage stresses, and may cause cracks. So misalignment of the weld, it will result in the difficulty in producing a sound weld and the stress concentration at this location, resulting in a reduction of fatigue life. So what is fatigue life? So we will simply say fatigue life is the number of stress cycles a material can withstand before cracking or failing due to repeated loading. So fatigue limit is there. It is often assessed by the fatigue limit, that is stress for 10 million cycles or crack growth models. So key factors are how it is measured, the cycles of to failure, number of load cycles until a crack propagates through the pipe wall. Fatigue limit, stress amplitude, stress level, the example 550 MPa for S135, at which the pipe endures 10 million cycles without failure. Stress intensity factor, used in models to predict the crack growth rates, example for oil and gas pipelines. Corrosion and voids can reduce the fatigue loss dramatically, with depth being particularly detrimental. Seismic load can cause failure in under 100,000 cycles, while the normal operations can reach millions. So specialized steels like P91 offer better thermal fatigue resistance, and 316L in power plants. So fatigue life quantifies the pipe's durability under repeated stress. With the design and material selection focused on preventing the crack initiation and growth, especially in the corrosive environments. So that is the fatigue life. So we are discussing here. So reduction of fatigue life fatigue life will occur if the joint alignment is not correct. So what will happen? There will be stress concentration at this location, and it will reduce the fatigue life. Then plate surface condition and the cleanliness, pre-cleaning prior to welding, it is important because inadequate cleaning can result in unacceptable levels of porosity in the completed weld. Other pre-weld inspection include preheat verification, temperature, heating method, presence and location of heat treatment monitoring devices, type and the efficiency of gas purging is applicable. So pre-weld inspection include evaluation and verification of documentation, material certification, filler alloy, welder performance qualifications, welding procedure qualifications, welder and welding identification for traceability and all. Now, inspection during welding, we are checking what the interpass cleaning methods, interpass temperature control, welding current settings, welding travel speed, shielding gas type, gas flow type, welding sequence, etc. And also environmental conditions such as rain, wind, extreme temperatures, etc. Now, the post-weld inspection includes to verify the integrity of the completed weld. Many non-destructive testing methods are used. However, if the before doing this NDT, it is normally wise to conduct a visual inspection first, because one reason is the surface discontinuities, which may be detected by the visual inspection, can sometimes cause misinterpretation of NDT results or disguised other discontinuities within the body of the weld. Most common discontinuities found during the visual inspection are conditions such as undersized weld, undercut, overlap, surface cracking, surface porosity, underfill, incomplete root penetration, excessive root penetration, burn through, excessive reinforcement. All these uh, all things we can find through visual inspection. If it is not found in the digital instrument, may this results of the NDT can cause misinterpretation or disguise other discontinuities within the body of the belt. So, by conclusion, a good pre-weld plan may be provide us with excellent opportunity to prevent the welding problems before they start. Though the direction correction of situation may cause welding problems, etc. So inspection conducted during the welding operation can detect problems before they escalate. It also helps to provide confidence in the final welded product. So also it is also good economical method of determining a weld's accessibility with regard to many surface discontinuities. Now, here, again, so it is mentioning about the cleaning of the visual before starting the welding. This some contaminants such as this oil, everything will cause porosity. What is this one? So, like we said, contaminants will cause porosity. Any blurs that remain can cause uneven melting, disrupt puddle flow, or snag the electrode, change the travel speed, misalignment of the pipes, can change the basic properties such as fatigue life. A pre-welding inspection sets the angle of bevel and the spacing and the fit up between these correct. In orbital welding, that is not we have not considered anyway. There is not root gap and the pipe faces directly about one another. Quality of tack welds and the alignment of pipes are to be checked. Sometimes inert gas are used in the interior to prevent contamination. So all these things to be checked as a pre-inspection weldings. During inspection, so during welding, we are checking for foreign material weld distribution, undercut, lack of side fusion welding, porosity, cracking. So what is foreign material? Slack. It should be easy to remove from the, if it is not chipped away easily, it may indicate an inclusion in the weld. If the welding is tension, it will be silicon slack points that float to the surface of the weld. So buffing to remove the slag between is normal. So this foreign material or slag to be removed during welding. The weld distribution. So a pipe welding inspection can quickly determine if this pattern is performed as specified. It should be evenly distributed across both workpieces without distortion. Visibly thinner material and due to bulging deposition of the metal. So this weld distribution is important because it should be evenly distributed without distortion. Visibly thinner areas and undue bulging deposition should be avoided. So it should follow a predetermined pattern. So this undercut, if welding filler material is not properly fusing, it can fall away from or both sides of the workpiece and into the weld itself. It creates a distinct scalloped pattern along the edge. So it can indicate that the heat isn't high enough or travel speed is too quick. Both issues can be resolved by adjusting the welding machine settings. So what is a scaffold pattern? So there is a distance is scalloped pattern. What is scalloped pattern? It will be like this. Okay. So this create a scalloped pattern along the edge of the weld. It will indicate heat is high enough and the travel speed is too high. It can resolve by adjusting the welding machine test settings. So there is a lack of sidewall fusion. Filler material will fail to bond with the side walls. If there is no enough heat input, travel speed is too low. If the workpiece is inertly cleaned, material inverts bonding of metals. In case of poor sidewall fusion, weld will need to be reworked, meshing, setting, tested, material cleaning of thoroughly, weld preparation practice reviewed for subsequent welds. Then porosity, the contaminants like oxygen, hydrogen melts into the weld. It bubble up on the surface. It leaves a distinctive pinholes, sometimes in large groups. It is called porosity. Indicates that all section of the weld need to be removed. Material thoroughly cleaned before welding can continue, and the cracking occurs when the weld is under stress. It causes maybe failure to properly mount a workpiece. So it remains chill while the weld cooled, misalignment of the two pipes, and structural stresses. Cracking can, why is cracking? Failure to mount properly, failure to properly mount a workpiece so that it remains still while the weld cooled. Means cracking occurs when the weld is under the stress, simply putting. Because of the misalignment, when the failure to mount the workpiece correctly, then other structural sectors. It also occurs when the welding two incompatible material, if wrong filler material is used, Cracking is also the result of metal changing temperature states too quickly. If the cracking occurs, piece positioning and machining settings also need to be adjusted. So mitigation of welding flaws depends upon the type of flaw and severity. Undercut at the side of the welds are only or poor weld distribution are only grounds for rework if it is severe and taking place in the industries. Usually, remediation is simply a matter of adjusting the welding machine settings and making sure subsequent passes have the proper distribution and the fusion. Foreign material in the weld porosity cracking means reworking at least a section of the weld and could require starting over with the new materials. It can be expensive prospects in some welding process and underlines the importance of visual inspections before starting and between the passes in order to remedy the flaws before it becomes larger problems. So welding inspections after the welding process, measurements of final bead profile for the fillet welds and legs of the fillet welds on both sides of the perpendicular weld piece must be within the specified measures like a not too short or not too large. Usually it is 0.75 throat thickness. Center or throat of the weld bead should be neither too convex or concave. Then the pipe to welds overall bead weld and height must be inspected to ensure within the specifications. Height cannot be too far above the joint or should not be concave or sink into the metal. So, common method of basic visual inspection is bring the pipe's interior pressure up to a level. So, it's checking it is, we are not interested, it is in the hydro test we are doing. Now this is orbital welding. Now here the pipe is chilling and still and the welding electrodes are moving. Sorry, the pipe is moving and the welding electrodes are still. So it is highly automated process. It can be more difficult for an operator to adjust the weld parameters while the weld is in process or to sense that something is wrong. For example, it is harder to register arc sputtering while watching the weld process remotely, removed from the physical feedback of the welding. The advantages of orbital piping outweigh the disadvantages. However, gaining full benefits like a fast completion of welds, machine precision, and the replicability requires stringent visual inspection before and during welding. A pipe visual inspection conducted will offer more benefit to the orbital welding and ensure practicality with beyond what is possible with manual welding. So this is not important. Now finally we will discuss some instruments we are using for the visual inspection. So this is a bridge cam gauge. Here it is we are using for measure the filler material. Here, sorry, fillet weld. Here we are using it for checking the reinforcement. Now we have high-low gauge is there. This one is a cam type gauge is there. It is cam type. Now we will discuss different gauges during welding. We will submit. So this is a high-low gauge. Here we can use to check the inside of this one, and we can check it. This one we can use it for checking the outside of the weld. Here is outside. Here we can put it into the root gap and measure the high-low. So this is high-low gauge, and previously we got the cam bridge gauge. Okay. So that's all for the visual inspection. We will continue with other video tomorrow.